last chapter we did one-step equations and two-step equations, and we're not going to call it that, but it's essentially three-step equations for this lesson. And this is the furthest we'll get as far as complexity in pre-algebra for solving equations. But there are times when equations with a variable on both sides needs to be solved. This requires one additional step to get the variable on one side only. So in all the one and two step equations we had, there was just one term with a variable. But sometimes equations will have a term with a variable on both the left side and the right side. So to do this, we will want to first combine the variables. So step one, now I'll go ahead and tell you, there's actually more than one way you can correctly solve it. But the way that I'm suggesting here will get it done the quickest and will work every time. So there are other ways, and if you use other ways and it's correct, that's fine. But I'm going to stick with this way because it will always make it the quickest and will always work. So the first step is to combine the variables. You'll need to either add or subtract, depending on whether the term is positive or negative, each term with a variable to one side of the equation. And you can pick whether you want them to move both to the right side or both to the left side. That part you really do have a choice. Now, after you combine the two variable terms, you'll want to move the constant away. And the reason I didn't say just combine constants is to make it as quick as possible to solve the equation. You want to add or subtract to move the constant that's on the same side as the variable to the other side of the equation. And then the last step will be to remove the coefficient. You'll need to divide by the coefficient to get the variable by itself. So combine the variables, move the constant away, divide to get rid of the coefficient. If you can remember those three steps, do it in that order, it'll work for you every time. Okay, so first of all, combine the variables. So on this first step, you really do have a choice. There's rarely a case where it'll matter. And by matter, I just mean it could make it shorter or longer, but that doesn't matter. It's just about making it correct. So like right now, you could choose to subtract 9x from both sides or subtract 3x from both sides. You can pick. Just because I'm going to subtract 3x from both sides. So 9x minus 3x is 6x. 3x minus 3x is 0. Now you could write 0x, but there's really no reason to write the x because 0 times anything is 0. So I'll just write 0. So I've got the first step covered. I combine the variables. By subtracting 3x from both sides, I now just have one term with the variable instead of two terms with the variable. So next I want to move the constant away. So you notice on the side with the variable, there's this minus 12. I want to move that over to the other side of the equation. I'm trying to separate the variables from the constants. So I will add 12 to both sides. Then my last step is to divide both sides by 6 because that's the coefficient and I need to remove it. So hopefully you see it's not that different from the two-step equations we did before. For the most part, it's just going to require that one extra step at the beginning to combine variables. Now, I did put just one example like number 2. If you notice, there is something a little bit different. This one actually has 3 terms of the variable. Now this is an exception I'm just showing for the sake of notes. You might see 1 or 2 in the homework or something like this. For the whole time we're working on this, it's not going to be common at all. But you see 1, 2, 3 terms with variables. So these two are on the same side. So the best thing to do is to go ahead and combine these two like terms. So I can say 15x minus 4x is 11x. So I did have to combine the like terms. That's not going to happen often. This is just a rare exception where you have to do that. But now we'll follow the steps we talked about up above. Combine the variables. You could subtract 11x from both sides, or you could subtract 8x from both sides. Either way will work. I'm going to subtract 8x from both sides. I'm just doing the other side this time to show you it can work just fine either way. 11x minus 8x is 3x. Okay, now step 2 says move the constant away from the variable, but actually in this particular problem, this will happen occasionally. This isn't as rare as this triple term thing with 3x's involved, but occasionally there will be no constant you have to move, so there's no constant, so I can skip step 2 and move on to step 3, which is to divide both sides by the coefficient. Negative 12 divided by 3 is negative 4. 3 divided by 3 is 1. So we get negative 4 is equal to x. Okay, number 3. So we have 6x plus 18 equals 6x minus 2. So obviously it doesn't really matter which one you do here because they're both 6x. So we'll subtract 6x from both sides. 6x minus 6x is 0, so that just leaves 18. 6x minus 6x is 0, so that just leaves negative. Oh, wait. Look at that. The variables just disappeared entirely. Now, these are special cases. When the variables disappear, what you have to do is look and see, does what is left make sense? Or is it true? Does 18 equal negative 2? No, of course not. So that means there is no solution to this. That means no matter what number you imagined or picked for x, this will never work. If you look at it, it says multiplying it by 6 and adding 18 would be the same thing, would equal if it multiplied by 6 and subtracted 2. Well, there's no way you can add 18 and subtract 2 and get the same answer. So this one has no solution. Now you can write no solution like I did, or you can write this symbol. It's a capital O or 0 with a diagonal line through it. That's a symbol in math that means no solution. Okay, number 4. We have variables on both sides. I'm going to choose to add 5x to both sides. You could add 2x to both sides and still get the correct answer. We get 0 equals 9. Negative 2 plus 5 is positive 3x. Step 2 is to get rid of the constant. So when you get rid of this 9, it's a positive 9. So I'll subtract 9 from both sides. 0 minus 9 is negative 9. Now we divide both sides by 3. Negative 9 divided by 3 is negative 3. 3 divided by 3 is 1. So we get negative 3 equals 1x. Okay, but I do need to back up because I forgot one part of the instructions. Check your answers. So let's go back and do that. Let me get a different colored pen. I think that'll help. Yeah. So I believe we talked about this with the other ones, but I want to show you at least with a couple how we can do this. So if I take 2, I should be able to plug it back in the original equation and it work. So I do 9 times 2 minus 12 equals 3 times 2. So you see I just took the 2 and I plugged it in for both the x's. 9 times 2 is 18. 3 times 2 is 6. And 18 minus 12 is 6. So it checks out. Okay, let's do the same thing with negative 4. I'm just going to go ahead and plug it in this one because no need to just make ourselves do an extra step here. So I do 8 times negative 4 minus 12 equals 11 times negative 4. So I just plugged it in this one where I'd already combined these two to be 11x. 8 times negative 4 is negative 32. 11 times negative 4 is negative 44. And negative 32 minus 12 is negative 44. So both sides check out. Well, I can't check this one because there is no solution. So let's check this one. If I plug negative 3 in for x, I get negative 5 times negative 3 equals 9 minus 2 times negative 3. Negative 5 times negative 3 is positive 15. Negative 2 times negative 3 is positive 6. And 9 plus 6 equals 15. So again, proves we did it correctly. I won't worry about doing that on the back, but I wanted to show you how to check your answers if you're asked to do it. Okay, number 5. We need to combine the variables first. So we have negative 8x, so we will add 8x to both sides. That gives us negative 10 equals negative 10. So something similar to number 3 happened here. The variables disappeared. But there is a difference between what happened in number 3, where we got no solution, and this one. In number 3, the result we got was false. 18 does not equal negative 2. But negative 10 does equal negative 10. So that means that this is always true. That means you have infinite solutions. Because if you look back, we had the exact same thing on both sides. Negative 8x minus 10, negative 8x minus 10. So any number you pick, if you do the same thing to it on both sides, you're going to get the same answer. So these will always be equal no matter what you pick for x. So you can write infinite solutions, or another math term or math symbol you can learn, a capital R with two backs like this. So it's a capital R, but it's got like two backs. That means all real numbers. So you can use this or this to answer that question. Okay, let's continue the three-step process. Number 6, we want to combine the variables. I'm going to choose to add 3x to both sides. 10x plus 3x is 13x. Now I want to move the constant away from the variable. Okay, so here, look, we have a constant here, 21. We have a constant here, minus 5. This is the one with the variable on the same side as the variable. So this is the one I want to move. So I'll add 5 to both sides, because that helps me get the variable by itself, which is what the whole goal is when we're solving. Our last step is to divide both sides by the coefficient. 26 divided by 13 is 2. Number 7, we want to combine the variables. You could add either one of these over. You could add 12x to both sides, or you could add 5x to both sides. I'm going to choose to add 5x to both sides. Now be careful with your negatives. I know these have x's, but you can use your calculator to help you with this, because you just tell the calculator negative 12 plus 5. And that tells you negative 7. So that's the coefficient that goes in front of the x. There is no constant on the same side as the variable, so we can skip step number 2. So we skip to step 3, which is to divide both sides by the coefficient. So our final answer is x is equal to negative 2. Number 8, we want to combine the variables. So there's a 4x, and remember, this is understood as 1x. It's not that x equals 1, it's that there's one of them. So I'm going to subtract x from both sides, or 1x from both sides. X minus x is 0. 4x minus 1x is 3x. Then we want to move the constant away from the variable. So we'll subtract 12 from both sides. Because it's a plus 12, the opposite is to subtract. Gives us 3x equals negative 6. Our final step is to divide both sides by the coefficient, so we get x equals negative 2. Okay, now let's take some real world stuff and see if we can translate it into math. And we can. Let's see how to. So twice Beth's daily pay. So we'll just call Beth's daily pay B. So twice B, 2 times B, is the same as, equal to, her daily pay increased by $45. So plus $45. Find Beth's daily pay. So twice her daily pay, 2 times B, is the same as, is equal to, her daily pay plus $45. So we're going to follow the same 3 steps here. Combine the variables. So this is 1B, so we'll subtract 1B from both sides. 2B minus 1B is 1B. And we're just left with 45. So we actually don't have to do more than that one step because there's no constant on this side, and it turned out there's no coefficient either. So we found out her daily pay is $45. Either this is in the distant past or she has a very short day. No way she could work a full 8-hour day and only make $45 an hour, but you get the point nonetheless. Last one, a number, you can call this X or N or whatever, but that's a variable, decreased by 12 minus 12 is the same as equals 3 times the number. Okay, so I'm going to choose to subtract 3x from both sides to combine the variables. Remember, this is an understood 1x. 1 minus 3 is negative 2x. Second step is to move the constant, so I add 12 to both sides. My last step is to divide both sides by the coefficient. So I divide by negative 2. My final answer is that x equals negative 6.